All right, chapter 10 is all about reasoning and proof. Chapter 10 is pretty basic, just logic, connectives. And chapter 10b is proof by deduction. So what is proof? First thing, some definitions. A conjecture is a statement or a prediction that we make after looking at a few examples and noticing a pattern. A counterexample is an example that makes the conjecture false. It disproves the conjecture. For example, if a is less than b, then a squared is less than b squared. Well, let's try some examples. Well, 2 is less than 2 is less than 4, and 2 squared is less than 4 squared, right? 4 is less than 16.
Mommy,
so that must be true.
Can you connect this?
Elsie, 1 minute. Can I finish this video? But let's try to find another example. Like, what if -2, pick some negative numbers, is less than, -2 is less than +1. But -2 squared is not less than 1 squared.
Mommy,
-2 squared is 4.
I'm
Okay, 1 second. I'm recording a video. I apologize that I'm recording a video and now I'm being interrupted. I thought I was safe, but I'm going to keep forging ahead. All right, so we get that when a equals -2 and b equals +1. This is our counter example.
I already did it.
What is proof? Proof is starts with it's right here. It starts with an assumption, a hypothesis, or a conjecture. And then you use a sequence of correct mathematical steps using logic, using deductive reasoning, and then we arrive at a conclusion. Our sequence of steps can include calculation or logic, definitions, theorems, or both. Why do we prove? We prove to convince people of something, to understand a concept better, to communicate, to organize, and mathematicians are constantly discovering new math through proof. Your tips on writing a proof. Start with stating what you're proving. Use details. Present calculations clearly and organized. Use diagrams when appropriate. Check to see that you've used each hypothesis from the beginning of your proof. And if you haven't, then maybe it was irrelevant or maybe you did your proof wrong. And then finally, it's a good idea for you to expect to not get it right the first time. You're going to have a rough draft, just like you would in an English paper, and make changes and adjustments as you go. All right, 10A, logical connectives. These are just some symbols that you might use. That word and is a connective. The symbol for and is that symbol, but you might also see it like this. We use that in probability. Or, same thing, you might see it like this. Negation, I've seen it like that in some books, some texts, but our text uses that. And this double arrow, or the double lines with the arrow, means if, like if it was P, Q, if P, then Q. And the double arrows means if and only if, or equivalence. So use symbols to write if A and B, then not C. A and B implies not C. So I could write it like that. What is the negation of x is an even number? The negation would be that x is an odd integer. Some symbols that you need to be familiar with in this section are the symbol for integer, the symbol for real number, the symbol for rational number. Integers are numbers without decimals. They could be negative, 0, could be positive. A real number could be any number that's not imaginary. So it could be square root of 2, could be 4, could be negative 1.3 repeating, could be negative pi. Okay, all those are real numbers. A rational number is a number that could be written as p over q, a fraction. So 1.3 repeating is a rational number, where pi is not. Pi is irrational. The natural numbers are 0, 1, 2, 3. Positive. Okay, so this notation could mean all of these different words: implies, then, so, hence, thus, therefore. A is your hypothesis, B is your conclusion. To write the converse of a statement, you switch the hypothesis and the conclusion. So B, if B, then A. And if both A implies B and B implies A are true statements, then we say that A and B are equivalent. A is true if and only if B is true. And that's how we would write it. 10b is proof by deduction. Proof by deduction uses a logical chain of arguments. It's a left to right proof, so you're only working with one side of the equation. If you remember back when we were doing trig identities, we were doing proof by deduction. Another symbol that you might see is this symbol with the 3 dots. It means therefore, so sometimes you see that at the end of the proof. Therefore, this is true. Prove by deduction. If x equals negative 3, then x squared plus 2x minus 3 equals 0. Well, I can just prove this substituting in negative 3 squared plus 2x, how about 2 times negative 3 minus 3. I get 9 minus 6 minus 3. 0 equals 0. So you can see that I'm only working with the left side of the equation, and I'm proving that I get 0. So yep, it's true, I proved it. So I could say, therefore, if x equals negative 3, then x squared plus 2x minus 3 equals 0. Explain why the converse is not true. The converse is if x squared plus 2x minus 3 equals 0, then x equals negative 3. So I'm going to start with this side, and it factors into x plus 3 and x minus 1. And so x equals negative 3 and x equals positive 1. And so this is false, and my counter example is that x could equal 1. Prove that 9a squared plus b squared is greater than 6ab for all a and b that are real numbers. So I'm going to start this one by subtracting 6ab from both sides. Oops. And then maybe it helps you if I write this as b squared minus 6ab plus 9a squared, because this factors into b minus 3a quantity squared. And b minus 3a squared is always positive. So this is true for all a and b that are real numbers. So therefore, 9a squared plus b squared is greater than 6ab for all a and b that are real numbers. This symbol just means is an element of. So they're an element of the real number set. So again, it was positive because any number squared is positive. All right, that's it for sections A and B, and I'll find a quieter time to record 10C.